All right, welcome to section 8.13. Today we've got three different items that we're going to be talking about. We're going to be talking about powers of complex numbers, how to find the distance of complex numbers, how far the complex numbers are apart from each other, and also how to calculate the midpoint, or the halfway point between two complex numbers. So our first thing we're going to do is we're going to start with our powers. So just to demonstrate why we have this power theorem that we're going to talk about, if I have -1 plus the square root of 3i and they want me to cube it, that doesn't mean that I'm just going to distribute the third power. It means I see this complex number 3 times. So in other words, it looks like this. -1 plus the square root of 3i, there's 1 time. -1 plus the square root of 3i, there's 2 times. And then -1 plus the square root of 3i, there's the third time. Now if these were just numbers and I had 1 times 2 times 3, I'd do 1 times 2, and then after I got that 2, I'd go 2 times 3, right? Well, that's what I'm going to do. I'm going to multiply these two first. Then once I get that answer, then I'll multiply it to this one. So it's going to take me a little bit of time, but hopefully it won't be too bad as we distribute. So -1 times -1 would be 1, so I distribute right here. -1 times square root of 3i would be negative square root of 3i, or you could put 1 square roots of 3i. So that's distributing here and here. And when I distribute here, I get negative square roots of 3i. And then when I do my last, I get square root of 3 times square root of 3, which would be square root of 9, which would come out as a 3, and then I times I is I squared. Now remember, I squared is -1, so this is really like -3. And -3 plus 1 will make that -2. When I combine these two together, remember there's like a 1 here and here, so that's -2 square roots of 3i. So that's what I got when I multiplied these two together. Now I need to multiply this third one. So -1 plus square roots of 3i. -2 times -1 would make a +2. -2 times square roots of 3i would make -2 square roots of 3i. Now I'm going to distribute to here. Negative times a negative will make a positive. On the outside I have 2 square roots of 3i. And then when I do my last one, I have -2 square roots of 3i times square roots of 3i. So a positive and a negative will make that a negative. And then on the outside I'll have 2. On the inside, I'm going to take this really slow, I'll have 9. And then I times I will be I squared. Well, the square root of 9 is 3, and I squared is a -1, times by this -2, so I have -2 times 3 times -1 will give me a +6. So 2 plus 6 will give me 8. And then these two will combine because they're both square roots of 3, so -2 square roots of 3i and +2 square roots of 3i cancel, and so that craziness is equal to 8. Now that's kind of beautiful actually, that worked out so nice and pretty. But what we're going to find out is that not only do we have to do it to the power of 3, but some of them on your assignment will be like to the 20th power, or the one in our notes today is to the 8th power. And that's not necessarily going to be the best way to do that, is to write that out 8 times down here and then start trying to multiply it all together. In fact, it gets quite complex. So a Frenchman named Morey, or however you want to say it, I'll just call it the Frenchman's theorem, came up with a way that if we have a complex number to a power, we can find out what it is using the pieces that we've talked about so far in Unit 8. So let me go ahead and give you his formula. He says that if I have any complex number, so remember the complex number system is Z, so this represents any complex number raised to a power. So this represents the power. So I have a complex number raised to a power. It will be equal to, and this is what he found, which to me is just truly remarkable. But he says r to the n, and remember r from 8.10 and 8.11, the r is the modulus. So you find the modulus of the complex number to the power, and then you multiply it by the cosine of the power times the angle plus I sine whatever the power is times the angle. And when you do that, you will get the final answer. So we're going to try that with the one that we just did up here, right? -1 plus the square roots of 3i. And so we should get an answer of 8. But now, instead of multiplying it out, doing it algebraically, we're going to use the Frenchman's formula. So I'm going to put in a number for here, here, the n, here and here, and then theta. So n is 3 places, the modulus is 1 place, and the theta is 1 place. So again, remember the n is the power, or the degree. The r is the modulus. And just recall that, remember, to find the modulus is that a squared plus b squared. It's the coefficients of each of them squared. And that theta is equal to the inverse tangent of b over a. Okay, so I've got to figure out what my n is. Well, that's just the power right there, so that's 3. I'm going to go find out my modulus and then my theta. Now, if it's -1 plus the square root of 3i, then that means if I were to go graph it for just a minute, my real piece is 1 to the right on my real axis, and then it's up square root of 3. So it's right here, it's in the second quadrant. That will be helpful for me to remember, especially when I go to find my angle. So, first r. Remember, r is the square root. Remember, this is your a and your b, your coefficients of your real and imaginary. So it would be -1 squared plus the square root of 3 squared. Well, -1 squared is 1. Zoom this up just a little bit so you can see it maybe a little bit better. And the square root of 3 squared would be 3. That'd be square root of 9, which comes out as 3. And 1 plus 3 is 4. And the square root of 4 is 2. So my modulus is 2. Now for my angle, remember theta is the inverse tangent of b, which is the square root of 3, over -1, which if I just clean that up a little bit, just move the negative up, is negative square roots of 3. So then going to my chart, because we need exact values, don't be punching it into your calculator, you need the exact value. The square root, I need negative square root, and I apologize for the glare, but hopefully you can see it. Negative square roots of 3 is right here, which is 120, or it could be 300. Well, as we graphed it, we know it's in the first quadrant, so it's going to be 120 degrees. That's what my angle is. So now I'm ready to put it into the Frenchman's formula. So r is 2, power is 3. Then I have cosine. It kind of feels like polar form right here a little bit. And then remember, it's the degree, which is 3, times the angle, 120, plus I sine of the same thing, 3 times 120. Well, 2 to the third means 2 times 2 times 2, which isn't 6. 2 times 2 times 2 is 8. And I'm going to take this kind of slow. 3 times 120 is the cosine of, 3 times 12 is 36, so 360. And then I sine of the same thing, 360. So now I'm going to go take my unit circle again because I want the exact value. And I go find cosine. 360 is clear to the end, is 1. And the sine of 360 is 0. So the cosine of 360 is 1. This one was 0. I don't want to forget my I. Don't forget to bring the I down. And I have it times by 8. Hopefully you can see how we're going to get to that answer of 8. 8 times 1 when I distribute is 8. And I distribute here, plus 8 times 0 would be 0i. Well, 0 times I would just be 0, so it's gone. So your answer is simply 8. All right, if you would like, you can pause the video and try B by yourself and then check back in and see how you did. Or you can just follow along with me. I would suggest maybe you try it yourself first, though. This time I have to go to the 8th power, so n is going to be 8. I need to find my modulus. That's the square root of, again, this is my a, and this is my b. It's a lot like a, problem example 1a, that I will have negative square roots of 3 squared. 2 negatives will make it a positive. Square root of 3 times square root of 3 would be square root of 9, which would come out as 3. Plus, and then remember the coefficient there is a 1 squared, which will be a 1. Which gives me square roots of 4, which again gives me 2. So my modulus is 2. Now for my angle, inverse tangent of b over a. So b is 1 over negative square roots of 3. Remember, it's the coefficient. Don't be writing down an I. So I'm going to times both top and bottom, rationalize that out a little bit. I'm going to choose to times it by excuse me, negative square roots of 3. So negative and negative will make the denominator positive and will come just as 3. 1 times negative square roots of 3 will make negative square roots of 3. And I can't do anything more to that, so I'm going to go find where that is on my unit circle. Negative square roots of 3 over 3. Oh, it's at 150, but it's also at 330. Well, where's this angle located? Well, negative square roots of 3 is the real piece, so that would go this direction, and then up 1, it will be in the second quadrant. So I'm going to use the one that's in the second quadrant, which is the 150 degrees. This is equal to 150 degrees. So now that I have those two things, I can now go plug it into the Frenchman's theorem. So here we go. My R, because we're plugging it in here, is 2. My N is 8, multiplied by cosine of N, which is 8, times my angle of 150, plus I sine of 8 times 150. I owe 2 to the 8th. Here's my calculator so you can see it. 2 raised to the 8th power is 256. And then I need to multiply this. Let's see, 8 times 150 is going to be a lot more than 360 degrees. In fact, it's 1200 degrees. We'll come back to what that means in just a minute. Oops, I don't need that parenthesis, sorry. I sine of 1200 degrees. I was thinking I was at the end, and I was not. Well, I can't do cosine of 1200. I need to be 360 or less in order to find its exact value. So there's two different ways you can do it. For me, the easiest way is just to take the 1200 and just start subtracting 360 degrees, or take off a rotation, right? Every rotation is 360 degrees. So I'm going to minus 360. That's 840, so still too big, so I'll minus another 360, take another rotation off. Still a little bit too big, minus 360. And so my answer is 120. That's not because it was a 0 here and a 0 there. That's not the reason. Don't fall into that trap. But it is the cosine of 120 degrees. So one more time, I had 1200 degrees, and I was just taking off, subtracting out the rotations. Now you could divide by 360 and see how many total rotations you had, but then you'd have to take that amount and subtract it from the 1200, which is actually more calculations. So I usually don't do it that way. I just keep subtracting 360 until I feel like I'm there. So the 120. So, all right, so now that I know it's 120 degrees, I'm ready to go ahead and find 120 degrees. And at cosine, it's negative 1/2. And the sine is square roots of 3 over 2. And I need to multiply 256 by it. So when I take 256 and I multiply it by negative 1/2, that's going to make negative, and half of 256 is 128. Oh, I almost forgot my I right here. So now I'm going to distribute the 256 to here. So that would be, just going to write this to the side just so you can see what I'm doing. I have 256 square roots of 3i over 2. Well, these two are both on the outside, so again, 2 are going to go into 156, or 256 128 times. So I have a plus 128 square roots of 3i. That's not as pretty as that 8th that we had. That's what's going to happen sometimes. They're not going to be pretty. In fact, the 3 that you do on your assignment, you're not going to get a nice, pretty number. You're going to get a complex number. You're not going to get just a real piece. You'll have both a real and an imaginary. So that's the first part of your assignment, is using the Frenchman's theorem to help you in finding a power. Okay, now let's turn the page. Last page. The first thing that it talks about is the distance. How do we find the distance between two numbers in a complex plane? Well, it says what we do is we find the modulus of the difference. Well, difference means subtracting. So they're telling us to subtract the complex numbers and then find the modulus. It's going to be the modulus of the difference. So the first thing that I need to do is find the difference between these two complex numbers. Difference meaning subtract, right? So if I have a complex number of negative 6 minus 2i, and they want me to subtract 2 minus 3i, and just subtracting them. So keep, change, or distribute this negative. Make that a negative 2 and a positive 3i, and then we'll just combine them. A negative 6 and a negative 2 will make negative 8, and negative 2i plus 3i will make plus I. So that's my difference, and then after I find the difference, I have to do the modulus. So now the modulus will be the square root of the real piece, which is negative 8 squared, plus the imaginary, the b squared, which is a 1, squared. Negative 8 squared is 64, 1 squared is 1, so that would be the square root of 65. And the square root of 65, it says here to just round to the nearest tenth. You don't have to do its exact value, so it would be 8.1. So that's how you find the distance. Now that's how it shows it in the workbook, but I want you to think about how we find the distance between two numbers in a real number plane. Well, if they're asking us to find the distance between two numbers in a real number plane, you've been doing this since your 8th grade math year. To find the distance between 2 points, you use the distance formula. And the distance formula says that you take your x's and you subtract them and you square them. And then you take your y's and you subtract them and you square them. That's like they put these two steps into one step. We subtract our x's, so it's negative 6 minus the 2. Remember, we subtracted and we're at negative 8. Then we square it. You subtract your y's, or in this case your b part, and you square it. So you could also just use the distance formula, or just use the distance formula, is how I would suggest that we do it, rather than doing their way of defining it by doing the difference and then finding the modulus of the difference. Let's just use that nice compact formula that they gave us. So remember the distance formula I'm just going to write down here. We'll use our a and b instead. So it would be a1 minus a2 quantity squared plus b1 minus b2 quantity squared, where this is your a and your b and your a and your b. And like I said, you've been practicing this for a long time. This isn't something that's new. So using the distance formula, it would look like this. We would have d equals big long square root. And we would take our real pieces and subtract them. So negative 6 minus 2, and they would square it. Plus then we would take our y's, or our b pieces, and subtract them. So negative 2 minus a negative 3, so that makes plus 3 squared. So I just look at my two numbers. I don't have to do that keep, change piece. I'm just plugging it into the formula. Well, negative 6 minus 2 would be negative 8 squared. See, it's right there. Plus, we have negative 2 plus 3. Well, that would give me a 1 squared. See, that's right there. And then that's 64 plus 1, which is the square root of 65, which still gives me an 8.1. So rather than doing it in two steps, you're just simply going to plug it into the distance formula like we've practiced over and over again in the last couple of years and getting your answer. So that's how I would suggest you do it, is use the distance formula. Okay, the other part that you'll have to do, and our last part, is we have to find the midpoint. So we have to find the distance, and again I'd use the distance formula, and then you have to find the midpoint. And it says the midpoint of a segment in a complex plane is the average of the endpoints. Well, that sounds very familiar to when it's in a real number plane. So remember, when we find the midpoint, we add our x's and we divide by 2, and then we add our y's and we divide by 2. But we're not in the real number plane, we're in the complex plane. So instead of x's, it's a. So we'll add our a's and divide by 2, and then we'll add our b's coefficients and divide by 2, right? Because we're finding the average, and that will be my ordered pair. So let's do our midpoint. So I have a negative 6 plus, remember it's always addition in between, 2 divided by 2. And then for my complex, or my imaginary piece, I have my negative 2 plus, and my b here is negative 3 over 2. Negative 6 plus 2 would be negative 4, divided by 2 would be negative 2. Negative 2 plus 3 would be negative 5 over 2. Since it doesn't divide exactly, I'm just going to leave it negative 5 halves. Now if I leave my answer like this is in rectangular form. So if they asked me to put it in rectangular form, that would be my answer. But they said find the complex number. So the complex number would be negative 2 minus 5 halves I. This is your coefficient for this is your real piece, and this is your coefficient for the complex piece. All right, so that's the second and third part. We found the distance, either using distance formula or the difference of the modulus, and then the midpoint. I'm just going to draw a line. Again, I would suggest you maybe pause the video and try B by yourself, or you can follow along with me. Welcome back. Hopefully you've tried both of them and are just going to see if you got the same answer as I did. So first I'm going to use the distance formula. So D is going to be equal to the square root of, I have 8 minus 1 squared plus negative 2 minus 4 squared. 8 minus 1 is 7. 7 squared is 49. Negative 2 minus 4 would be negative 6. Negative 6 squared would be 36. 49 plus 36 is the square root of 85. And again, they want us to round to the 10th, so my answer would be 9.2. For my midpoint, we'll have our x's added, so 8 plus 1 divided by 2, and then our, sorry, I said x's, our a's added, and then our imaginary pieces, negative 2 plus 4, remember it's addition in between. 8 plus 1 is 9. 9 halves doesn't divide exactly, so I'd leave it 9 halves. Negative 2 plus 4 would be 2. 2 divided by 2 is 1. Again, that's in rectangular form, so writing it as a complex number, it would be 9 halves plus I. And we have now finished Unit 8. This is the last part of Unit 8. We found out how to find powers using de Moivre's theorem, how to find the distance between two complex numbers, and also how to find the midpoint. Good luck on your assignment.